Good evening, Mario J Warriors. Welcome aboard. And it's time for the most important questions and the concepts which are frequently asked in the VITEEE examination. As you all know, VITEEE is one of the most sort of examination, one of the most important private college entrance examination for all the students who want to keep a backup or who have lost hope in J. And trust me, the competition is very intense even in this. You need to secure a good rank in VITEEE to get a top-notch branch. So let's aim for the best. Let's do the top important topics as well as their questions. Okay. Coming up very shortly, guys. I hope I'm audible and visible to all of you. Hi Mohan Raja, hi Soumya, hi Aradhya, Devil, Sivaram. Good evening. Good evening, Sugant. Hi Moonleaks, hi Winter. Welcome, welcome, welcome. Looks like I'm audible and visible to all of you. Perfect to all my warrior pandus. Yes, I'll be taking one more class. Guys, do you want a class on English and aptitude? Well, I'll be taking it up very shortly after the UGEE session. So by this week only, we'll be completing that. Okay. So let's get started with the session. Make sure you have subscribed to the channel because all important sessions are lined up for all your entrance tests, and also show your love and support. If you want me to conduct all types of questions for aptitude, all types of questions for English, every single type of question which can be asked, a complete detailed session, not a random session, right? If you want me to do that, quickly smash that like button right away right now. Good evening, guys, and let's start with the questions. But before that, first the important topic. Okay, so we'll be doing topic questions so that we revise theory quickly and go to the questions. Remember Coulomb's law, which says that the force is nothing but 1 by 4 pi epsilon naught. The charges are there on the top, the product of the charges, and inversely proportional to the square of the distance. This could be your charge 1, this could be your charge 2. This is the distance between them, and yes, the force between them is represented as your F. And this particular value that you have over here, that is your Coulomb constant, having a value of 9 into 10 to the power 9. This epsilon naught is the permittivity of free space, which is 8.85 into 10 to the power minus 12. But any permittivity of the medium is always a relative permittivity, which I can also call it as the dielectric constant into permittivity of free space. This is then your dielectric constant. Dielectric constant. Keep this in mind. Whenever there are more than one charges, here, etc., and you have another charge over here, then this charge will experience force due to this guy, 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 and there will be obviously a net force. So the net force is nothing but a vector sum of all the forces acting on it. Sometimes you might be asked to find the force due to the field, and maybe there is an electric field somewhere. There is an electric field somewhere, and maybe you have placed a charge inside that field. So the force always acts tangential to the field, and that force is given by the charge multiplied by the electric field. If the charge is positive, force is in the same direction as of the field. If the charge is negative, the force is opposite to the direction of the field. So these are some basic concepts. Let's have a look at the question coming up on your screen. 3-point charges are placed in a straight line, 0, L by 2 and L. The net force on charge Q is 0. So what do you think is the value of capital Q? Okay. All right. Let's see. For MET also, you can watch this session, my dear friend, because obviously the questions will be of the same level. So you can watch this. Okay. It's definitely going to help you there. Okay. So what is it? 4Q, Q and Q. So let me show 4Q over here. Length 0, L by 2 and L. So the next one is basically Q, and in between of that we have capital Q, and it is given 0, L by 2 and L. That means this is nothing but L by 2, and this is also L by 2. And the question says that the force on charge small q is 0. So on this guy, the force is 0. So this 4q and this small q will obviously repel each other. So there is a force of repulsion. Let's say I call it F1. So this capital Q must definitely attract it. Only then it can cancel it so that the net force is 0. So since the net force on that is 0, therefore the forces should balance each other out. Therefore F2 should be equal to F1. F2 is because of Q on small q. So the force will be given by 1 by 4 pi epsilon naught capital Q small q divided by the distance, which is L by 2 square. This is all magnitude wise. Please understand that. I'm just taking the magnitudes everywhere. I'm just equating the magnitudes of the forces will be equal. And on the right hand side, the force due to 4q on small q will be 1 by 4 pi epsilon naught 4q small q. The whole distance is L, so L square. This is again the modulus. 1 by 4 pi, 1 by 4 pi epsilon cancels, L square cancels. So we will be having capital Q, small q, the whole thing divided by 1 by 4 over here. And over here 4 small q square. Actually, q square is always going to be positive, but still if you want, I'll put q into q and nothing is there over here. So what I can further cancel is this q over here and this q over here. This 4 will go on the top and it will eventually cancel with this guy. It will eventually cancel with this guy. So what am I left with if this 4 cancels with this guy? The magnitude of this q is the magnitude of small q. So magnitude wise they are equal, but since they are attractive, sign wise they should be opposite in nature because they are attracting each other, so they should be negative. So hence capital Q is negative q, which is option A. Very good. Ragesh, Sweta, awesome, awesome. All right, all right. Yes. So let me tell you, my dear friends out here. Hi, Somya. Let me tell you, you cannot do these questions within 2 steps. If somebody is telling you you can do it with 2 steps, please let me know who that person is. Many people think, I know VITEEE Triple E exam is only conducted in 2 minutes only. You get barely 1 minute 20 seconds. But the point is, I'm explaining here on the entire solution. When you actually solve in the exam, obviously you will not write balanced word, you will not use this word, and you will not write 1 by 4 pi epsilon also in your head. You know it is going to get cancelled. So your mental calculation will be like, q, okay, divided by L by 2 square will be balanced by 4q divided by L square. So that is all that will be there. 1, 2, 3. 3 steps will be there. That's it. You will not be doing all these things. Is that right? Yep. All right. Moving on to the next question. Electric field related concept. Electric field. All right. So we all know electric field is the force per unit charge. Yes, electric field. Remember, it is nothing but the force per unit charge that we have. Yes, and and the electric field due to a point charge. Quickly, let's revise the formulas. Due to a point charge, what is the electric field, guys? Due to a point charge, what is the electric field? It is nothing but Coulomb constant Q divided by R square. Similarly, if you have a shell, then once you are outside that particular shell at a distance of r, the electric field is given by the same formula, kq divided by r square. It's just that when you're inside, no matter where you are, the electric field is going to be 0 for a shell. Similarly, if you have a solid sphere, if you have basically a solid sphere, if you have a solid sphere which is uniformly charged, then when you are outside, again the formula is the same only. So electric field is given by q divided by r square. But when you are inside, be careful, guys. Yes, the electric field inside is given by kq small r divided by radius of the sphere cube. Radius of the sphere cube. That is the change over there. Next important thing, if you have a line charge like this and you are at a distance of r from it, the electric field is given by, your 2 times k lambda divided by r. So due to a line charge which is infinitely charged like this, yes, it is given by 2k lambda divided by r. Similarly, if you have a sheet which is charged, then the electric field is always going to be uniform. The electric field is going to be uniform and it is given by sigma by 2 epsilon. Yes, the electric field will go both the sides. It will go both the sides. So these are some standard formulas which you must definitely know. And one last formula which you should know is for a ring, guys. Yes, if you have a ring which is charged, then on the axis of the ring, the electric field is given by Coulomb constant charge multiplied by x divided by r square plus x square raised to 3 by 2. So these formulas will help you solve many questions. All right. So let's have a look at the questions. Well, we have a hollow insulated conducting sphere given a positive charge of 10 microcoulomb. What will be the field at the center of the sphere if the radius is 2 meters? Well, at the center of the sphere, guys, obviously it is conducting in nature. No matter where you are, electric field inside is always zero. Please remember, it's a conducting sphere, so the charges are only there on the periphery. So the answer is obviously option number A. Is that right, everyone? Okay. All right. All right. Cool. So moving on to the next one. So guys, do you not want me to revise the theory? If you just want the questions, I can just directly skip the theory and go to the questions then. That can make the session faster if that is what is the need. Yeah. All right. Very good. Moving on. A hollow sphere, insulated conducting sphere is given a positive charge. What will be the field at a distance of 1 meter from the surface on either side of it? Oh, either side of it. So imagine this is your sphere. This is basically 2 meter. So 1 meter inside, though, it is very obvious. Here, the electric field inside is obviously zero. But if you go 1 meter outside, the total distance from the center is basically 3 meter. So at this particular point, the electric field will be Coulomb constant Q divided by R square. Coulomb constant is 9 into 10 to the power 9. Charge is nothing but 10 micro. So 10 to the power minus 6. Distance is nothing but 3 meters. So 3 square. Now 3 will cancel. Sorry, 3 square and 9 will cancel. And this will become 10 to the power 10 into 10 to the power minus 6. So it will become 10 to the power 4 Newton per Coulomb. So that is the answer outside. Is that okay? All right. All right. Okay. So in an ideas, most of the students need the formula revision. So that's why we will be doing it because that's what the session also meant today. It's okay. It might take a little time, 1-2 minutes extra for every question, but that's okay. All right. Next, electric potential energy. Quickly. So if you have a point charge and you are at a distance r, then the electric potential at that particular point is given by kq by r. But similarly, if you had two charges separated q and q by a distance of r, then the potential energy is given by k, Coulomb constant qq divided by r. So one more charge will come for potential energy. So how are the potential energy and potential also related to each other? Let's talk about that. So a change in the potential energy is always the charge which you take from one potential to another potential. So potential difference. So potential energy change is always charge into voltage difference. And this potential energy change is also the work which will be done externally, but it is also negative of the work done by electric force. So this is a very famous equation which you must definitely know. Not just that, also remember that if I want to find the electric field, I can just take the derivative of the potential with respect to the distance with a negative sign. And similarly, the electric force will be negative of derivative of the energy with respect to the distance. All these formulas very, very important, of course. All right. So keep these things in mind. So maybe we can start solving some questions on this. Four particles, each having charge q, are placed at the vertices of a square. The value of the electric potential at the midpoint at one of the side. Be careful. What is the question? Read it carefully. The question says, what is the electric potential at the midpoint of one of the side? So quickly draw the diagram. So quickly think about the diagram. This is how it is going to be. Okay, this is A, this is also A, and you have to find the potential right over here. So there are charges, which charges Q. So there is a charge Q over here, this is a charge Q over here, there is a charge Q over here, there is a charge Q over here. Now the easy part is over here. This charge and this charge are at a distance of A by 2 and A by 2 respectively. So when I calculate the net potential, the potential due to this and this charge will be equal. It will be K Q divided by distance, which is A by 2, plus again K Q divided by A by 2. So this and this K Q by R formula, I will get the potential due to both these charges. Okay. Next is this charge and this charge. This charge is at this particular distance. How much is this distance? Use Pythagoras. Yes, even this distance. So let's say I call the distance D. That will be root of, this side is A and this side is A by 2. So A by 2 whole square. So A will be common. So 1 plus 1 by 4. So LCM is 4. So it will become A by 2 root of 5. So root 5 A by 2 is the answer for that. So plus K Q divided by A root 5 by 2 plus K Q A root 5 by 2. That's it. So I can see a lot of terms are common, guys, like K Q by A, and 2 is also common. And here you will get 1 plus 1 plus root 5 plus root 5 is below, my bad. 1 by root 5 plus 1 by root 5. So this will become 2kq divided by a, 2 plus 2 by root 5. So 2 also you can take common. So it will become 4kq divided by a, 1 plus 1 by root 5. Is that right, everyone? Yep. So check this out. I think this answer only, B option, is correct. We didn't have to solve it till this step. Yeah. So 1, 2, 3, 3 steps, and this particular geometrical step. So 4, 5 steps, you'll get the answer. Yeah. I hope this is absolutely clear. This is not correct, guys. This is not correct because you can see that number 1 is there inside. So here we have 2. So D is not correct, guys. B is the correct answer. So many of you made a mistake over here. In all cases, field is 0. Any exceptions? SS only for solid sphere. Like I mentioned over here. Where did it go? Solid sphere. So when you have solid sphere, the field inside is not 0. It is proportional to R. Okay. So when it is a solid sphere, which is non-conducting in nature, uniformly charged, only then it is not 0. Okay. I have given that formula. Perfect. Let's go, guys, to the next question on your screen. The electric field in the region is given by m by x raised to 4. Then the correct expression for the potential in the region is, potential at infinity is given to be 0. How are you going to solve this? I think field and potential are related. Use that concept. Field is negative dV by dx. Yes, and the field is given by m by x raised to 4. This is minus dV by dx. Rearrange it. So I will get negative dV is equal to m x raised to minus 4 into dx. So dx goes on the top, x raised to minus 4 goes on the top, minus dV stays as it is. Obviously, the next step is integral. So integral and integral. Limits of the integration. When I'm at infinity, the potential is 0. When I'm at x, the potential is V. That's all. So what do we get? Minus, first put V, then put 0. Integration dV is V only. Then m is there. This will become x raised to minus 3 divided by minus 3. And then put the limits, infinity and obviously x. Let's solve this. So this will become minus V is equal to m. First put upper limit. So it will become 1 by minus 3x cube minus 1 by minus 3. Instead of x, you are going to put infinity, the lower limit. Yes, infinity cube. So what will happen? So this will become minus V is equal to m into 1 by minus 3x cube. This number, infinity, 1 by infinity is 0. So this is just 0. So minus minus cancels. So V will be equal to M divided by 3x cube. M divided by 3x cube is just right over here, option A. That's the answer. Is that right? Everyone? Absolutely. Okay. Yes, the final answer key for the JEE mains will be released. Don't worry about it. Cool. Shall we go ahead to the next question coming up on your screen? Gauss law related questions. Yep, let's do the questions related to Gauss law. The Gauss law says that, first of all, electric flux. Electric flux is nothing but the electric field dot the area vector, which is nothing but EA cos theta. So if this is your area vector and this is your electric field vector, yes, area vector is always perpendicular. So this angle over here is theta. And if you take the flux for any closed surface, it is always whatever total charge is there inside divided by epsilon naught. Total charge which is there inside divided by epsilon naught. So that is what this is all about. All right. So let's do some questions. 8 dipoles of equal magnitude are placed inside a cube. The total flux through the cube will be how much? What is the total flux through the particular cube? Come on, guys. This is very simple. Now, if there are 8 dipoles, that means one positive, negative, positive, negative. Like that, there are 8 such charges. So if you ask me, what is the net charge which is there inside? How much ever positive, that much ever negative, it will always be 0. And the answer why it is 0 is because it is a dipole. Equal charges of same magnitude, opposite sign. So if the total charge inside is 0, by Gauss's law, what should be the total flux through the closed surface? It should be also 0. So the answer is definitely a D. Got it, my dear students? Perfect. Very good, Shweta. Very good, Rajesh. Very good, Sobin. Awesome, awesome, Sachin, Yashwant. Great. Yes, Jarvis. The option is D. Hello, Duganapali. Manipal, you can watch this, or I mean, not many people are giving Manipal. If you are giving Manipal, then we can think about it. So please let us know. Next question, consider an electric field which is going in the X cap, means I cap, that means this direction. And there is a slanted area as shown. Find the flux through this. Okay, electric field is going here. So this is a slanted figure. So I will visualize this in slightly three-dimensional diagram. So it will be easier for me. So observe this. I'll just draw few lines like this. Okay, just look at this part, which is the horizontal part, versus look at this vertical part over here. This is just to make you visualize how that tilted diagram is. Now this obviously shading part, etc., you're not expected to do. This is just to make you visualize how that diagram is. Are you able to visualize? It's tilted. The red one is the horizontal, the green one is the vertical. And observe how the electric field lines are exactly coming. That will give you some idea. The electric field is going along X direction. So they are coming like this. They are coming basically like this along the X direction. Yes, they are coming along the X direction, my dear students. They are coming like this. So tell me one thing. Obviously, if the electric field is coming along the X direction like that from there, so whatever flux will pass through that shaded area, whatever flux will pass through that shaded area will be the same flux through the vertical area, because the reason is the same number of lines, same number of field lines are going to cut through it. Whatever field line will cut through the slanted part will eventually cut through the flat part vertical. This field line would have cut through the slanted line. Do you agree with this? Yes or no? Understood? Definitely. So through this part, what will be the flux? The flux will be obviously the field which is going, which is E naught, multiplied by the area of that. So what is the area? Well, the height will be A, The base will also be A. So it will be nothing but A multiplied by A, which is E naught A square. So E naught A square is C option. That's it. So very direct question if you are able to visualize it like this, or else you'll think, what is this? Should I write it in vector form? Should I take dot product? Nothing of that sort was needed. Okay. Moving on to the next question coming up on your screen. Let's talk about capacitors. Well, capacitors are energy storing devices. So one positive charge, one negative charge. Over here, this has capacitance C and maybe some voltage V across the ends. Then the charge stored on it is capacitance into voltage. The energy stored in a capacitor is basically half CV square. If somebody decides to add some material in it, some dielectric constant K, then the new capacitance is always K times the older capacitance when you add some dielectric medium in it. When you add some dielectric medium inside of it. If you have a parallel plate capacitor, the capacitance of a parallel plate capacitor is epsilon naught A divided by D. If dielectric medium is there, you multiply by K. Yes, that is very important. Also, there is force between the plates of a capacitor. That force between the plates of a capacitor is charge square divided by, what is it? 2a epsilon naught. Charge square divided by 2a epsilon naught. But if you ask me what is the field between the plates, what is the electric field between the plates, then the answer for that is Q by A epsilon naught. There is no 2 over here. There is no square also over here. So these are the formulas which you should definitely remember, my dear students. Okay, cool. Shall we do some questions? But before that, well, let's do one more thing. Yes, when capacitors are in series, then use 1 by CS parallel formula of resistors. In a hurry, many people do this mistake. They realize it after coming out of the exam hall. Oh my God, I used it like resistors. So if they are in parallel, then just add the capacitor C1 plus C2. Do not ever do this mistake where you forget to switch the formulas between the resistors and capacitors. Okay, this is a VITEEE 2023 question. There is a parallel plate capacitor and it is connected to a battery and then disconnected from it. Okay, so just imagine there is a parallel plate capacitor and you're connecting it to a battery. Obviously, this will be positively charged, negatively charged. If you disconnect it from the battery, still those charges will be there. Still those charges will be there because the charges have nowhere to go. You have just disconnected it. Now what you have done, you have placed a dielectric slab inside of that. Then you have basically put a dielectric slab, then you have put a dielectric slab on it. So this is positive, negative charge. Now you are placing a dielectric slab in between them. So what will happen? In such a process, when you are basically, it's clearly mentioned that you are disconnecting it, then the charge will remain the same. The charge is always going to remain the same. So if it was plus Q minus Q, it will be plus Q minus Q, it will be plus Q minus Q. Rest of the things will change. Obviously, capacitance would have changed. The new capacitance will be K times of C. Even the energy will have changed. Energy will be Q square divided by C. Sorry, capital Q square divided by 2C. So this C would have changed by K times, So obviously the energy would have become 1 by K times. The energy stored in it will become 1 by K times. So energy stored will change. Charge on the capacitor is not conserved. In fact, this is wrong. And see the question, what it says. It's a very tricky question, which is incorrect. The charge on the capacitor is not conserved. This is 100% incorrect. Yes, the charge should be conserved. So not correct option is option C. Yes, it is the incorrect option, which you have to mark. Yeah, potential will change. Potential will definitely change because again, you can see Q is equal to CV. Charge is same, so capacitance will increase, so voltage will decrease. So voltage will decrease, energy will also decrease, capacitance will increase. So lot of things are changing except for the charge. If it was connected to the battery, then voltage will remain the same. if it was still connected to the battery while placing the slab, only voltage will remain the same. So because capacitance increases, the charge will change. So in each case, one of the things will remain constant, the other things will change. Is this absolutely clear? Parth and everyone else? Is this absolutely clear, my dear students? Never ever make this mistake now. Pakka? Shall we go ahead to the next question coming up on your screen? The circuit shown below, find the capacitance if the effective capacitance of the whole circuit is 0.5. Okay, so let's see what and all are in series, parallel, etc. These two, find C. Okay, we have to just find C. These two are in parallel, so this will become 4 microfarad. These two are in series, so series, they will become less, so half of 2 will become 1. Remember, whenever equal capacitors are there in series, it will become, you know, how many ever capacitors you have, you divide the capacitance n times. If they are in parallel, you multiply the capacitance n times. So 2 capacitors in parallel, so 2 into 2, 4. 2 capacitors in series, 2 by 2, which is 1. This one and this one, this one and this one, they are in parallel. So 1 plus 1 is going to be 2. Okay. Now, next thing. Okay. Again, look at this. This 2 and this 2, they are in series. So they will again become 1. They are in series. So again, they will become 1. Okay. So we have a capacitance of 1 and 4 over here. So if you observe carefully, we have a capacitor of 1 and then we have a capacitor of 4 over here, and they are connected like this to this particular point B. And yes, we have one more capacitor over here whose capacitance is unknown. Now they both are in parallel. Obviously, they both are in parallel. So if they are in parallel, their capacitances will add. So it will become 5, and this is nothing but B. Now they are in series and their whole capacitance is given to be 0.5. So their net capacitance is 0.5, which means you can say that 1 by 0.5 will be 1 by C plus 1 by 5. Is that clear, everyone? So this is what you are going to do. 1 by 0.5, that is nothing but 1 by 2 over here. Take that 1 by 5 on this side. So this will be 1 by C. So this will be 10 minus 1 divided by 5 is 1 by C. So 10 minus 1 is 9. So 9 by 5 is equal to 1 by C. So therefore C is equal to 5 by 9. I think some mistake is there somewhere. Just check if you have made anything. All values are in microfarad. Just check. 2 and 2, it is nothing but 1. Just check it out. Yes. So 2 I have missed. Where did I miss? 2. Oh, this 2 I missed. Oh, sorry. See, this is a blunder. This is a silly mistake. So sorry, guys. I think I missed one capacitor somewhere. Yeah. So this is 4. This is 4. Okay. Now this 4 and 2, they are in series. They are in series. So capacitance will be 4 into 2 divided by 4 plus 2. Yes, they are in series. So 4 into 2 divided by 4 plus 2. 4 2s are 8. 4 plus 2 is 6. So this will be 4 by 3. Is that right? Okay. So over here, again, I will get a capacitance of 4 by 3. Just check this out, everyone. Yes. So this is 4 by 3. 4 into 2 divided by 4 plus 2, which is 6. So 8 by 6. So divide by 2, divide by 2. Is that now okay? Perfect. Yes. All right. Next. Anything else missed? Everything else we have taken? Everything else we have taken? Okay. Yes. Perfect. Okay. So now what is the effective capacitance of both of them? So this is basically C, and these two are in parallel. So add them completely. So 1 plus 4 by 3, which is 3 plus 4, which is 7 by 3, which is nothing but 7 by 3. So this is your point B and this is your point A. Yes. So this is basically 7 by 3. Now you can do 1 by effective capacitance is 0.5 is 1 by C plus 1 by 7 by 3. So 1 by 0.5 is 2 by 1. This 7 by 3 goes on the other side as 3 by 7. And this is 1 by C. 7 2s are 14. 14 minus 3 divided by 7 is 1 by C. This is nothing but 11 by 7 is 1 by C. So C is nothing but 7 by 11. So 7 by 11 is option A, which is the correct answer. Is that okay, everyone? Perfect. Okay, great, guys. Let's move to the next concept. What is the next concept? Drift speed, current is equal to NVIDIA, very famous formula. I is current, N is the number of charge carriers per unit volume, VD is the drift speed, E is the electron charge, A is the area. You can also write drift speed as electron charge into electric field divided by mass of the electron into tau, which is the relaxation time. Also remember that mobility is nothing but how much drift speed is there per unit electric field. All these concepts are related to electric field, drift speed, all these things. So remember all these formulas. Some additional formulas will be electric field is resistivity into current density, where this current density is nothing but current by area. Resistivity formula comes from here. Resistance is a rho L divided by A. An electric field comes from voltage per unit length. And this formula is very much similar to voltage is equal to IR, which is your Ohm's law, which is your Ohm's law. All these formulas very important, my dear warriors. Okay, so let's see some questions then. There is a silver wire whose radius is given, and current is also given. The density of the charge density of the silver is also given. The drift speed is. This is now direct question. I is equal to NVIDIA. Okay, so VD will be I by NEA. What is the current? Current is 2 amperes. What is N? Number density. It is already given. 5.86 10 to the power 28. Electron charge 1.6 10 to the power minus 19. What is the area? It is nothing but pi r square. So 3.14 into radius square. 0.1 centimeter is, how much is 0.1 centimeter? 10 to the power minus 3 meters. So square of it. So 10 to the power minus 3 is square, guys. That is what you are going to get. Now solve this. You will approximately get the value of the drift speed. Yep, solve this, you will get the value of drift speed. If you check the powers, minus 6 is there over here. Minus 6 and minus 19 will make it minus 25. So 10 to the power 28 and 10 to the power minus 25 will make it 10 to the power 3. So on the top, it will become 10 to the power minus 3. But apart from that, you also have 5, 1.6 and also 3.14. So you'll have to take care of it. So approximately, if you ask me, like this is like almost like 1.6. I can take it as 1.5, which is like 3 by 2, and this is almost like 6 only. So 6 by 2, mentally I'm doing it, 3 into 3 will be 9. 9 into 3 is 27, and this is almost like half of 2 by 27, almost like that. 2 by 27 kind of thing. So almost like 0.7, something like that it might be. Yeah, it might be close to 0.6, 0.7. Yes, check that out. Almost very close to that. And this was 10 to the power minus 3. So if I write it almost like 0.07, it will be. Yes, 0.06, 0.07. So almost it will be. So if it is like 0.06 we had and 10 to the power minus 3 we had. So this will become 0.6 into 10 to the power minus 4. Yeah. So I think it should be answer C approximately. Yes, it is. It is. So you can do approximate calculations. Don't have to sit and do exact calculations. Yeah. Charge density and E are same. No. See, don't get confused. This is number of charges per unit volume over here. This is your 1.6 10 to the power minus 19. Don't get confused. This N is what was given over here. Okay, clear? All right. All right. Maths lecture will be there. I mean, it should be scheduled. I'm not sure. It should be there today evening. Just check it out. Yeah. Or it would have happened in the morning, right? If I'm not wrong. Did it not happen in the morning? Hmm. All right. Let me just see what happened later on. Okay. I'll check on that, guys. Maths class, whatever happened. Okay. 7 p.m. maybe. Okay. Okay. I'm not really sure. Okay. Cool. Fine. Wheatstone's bridge related concept, guys. Let's look at that as well. Okay, Wheatstone's bridge. Wherever you have some resistors arranged in this particular format and you have some device connected over here, voltmeter, galvanometer, resistor, capacitor, whatever, and this is connected across a battery. If this is R1, this is R2, this is R3, this is R4, then if R1 by R2 is R3 by R4, then it is said to be balanced bridge. Then it is said to be balanced bridge. And when that happens, the current in this part will be zero. You can completely neglect this. You can completely neglect this. And this is a standard form of the Wheatstone's bridge. But also remember, even this is a Wheatstone's bridge. You take a resistor here, take a resistor here, take a resistor here, then put a resistor like this and put a resistor here like this. Yep, even this is a Wheatstone's bridge, guys. A lot of people do not realize this is R1, this is R2, this is basically your R3, and this is R4, and this is that middle part which you can completely ignore. Yeah, so this is also a disguised way of looking at Wheatstone's bridge. And also remember one important thing, this is also applicable for capacitors. Also applicable for capacitors. So if you have capacitors, C1 by C2 is C3 by C4, then this middle part is completely useless. No current will go because both these points will be equipotential. Yeah, both the points are equipotential. Okay, great. So shall we go ahead to the question then? Yep. To calculate the relaxation time, you can use directly this formula. If you know the drift speed, you can find the relaxation time. Yeah. So directly from this, you can calculate. Okay. So drift speed can be calculated using this. Usually current, something might be given. So that is one way to do that. Magnitude of resistance X so that no current flows through the 5 ohm resistance. This is again a Wheatstone's bridge. So no current should go through this resistance. That means it should be balanced in nature. So this resistance of X divided by the other resistance 18, this branch we have 2 ohm and we have 6 ohm. So X will be 2 by 6 is 1 by 3 multiplied by 18. So that will be 6. So answer is 6 ohm. Yes, perfect. So sometimes you get very laddu questions also. Okay, cool guys, devil, perfect, awesome. Let's go. Let's go, let's go, let's go, let's go. Okay. Moving on to the next set of questions, resistance. Simple formulas R is equal to resistivity L by A. But sometimes when you have stretching problems, a resistor is there and you are pulling it and stretching it, then the volume will be constant. Keep that in mind. So resistance will become rho L square by volume. So then it is proportional to the square of the length because the volume will be constant. These kind of questions also do come. Also sometimes resistance as a function of temperature, which is R naught 1 plus alpha into the difference of the temperature or the change in the temperature. That's another formula which you might use. And series parallel to everybody knows. So in series, current is basically the same and the total voltage is V1 plus V2 plus Vn like that, and the total resistance in series is R1 plus R2 plus like that Rn. Whereas in parallel, it is the voltage which is the same, but it is the current which gets distributed I1 plus I2 plus IN, and 1 by RP will be 1 by R1 plus like that till 1 by Rn. So that is for parallel. So we know these things. So let's have a look. VITEEE 2024. If you are provided with resistances 2, 4, 6 and 8, connect these resistances so that you can obtain an equivalent resistance of 46 by 3. So that you can obtain an equivalent resistance of 46 by 3 ohms. Come on, my dear students. Come on, my dear students. What are you going to do? How do you combine 2, 4, 6 and 8 to get 46 by 3? Try out different combinations. Worst case, if you are not able to think, try to eliminate it with options only. Okay, so just try out randomly any of the options. Let's say I try the option, this one, 4 and 6 are in parallel, so it will be 4 into 6 divided by 4 plus 6, so 24 by 10, which is 12 by 5, and are in parallel with 2 ohm and 8 ohm, which are in are 4 ohm and 6 ohm are in parallel with 2 ohm and 8 ohm in series. 2 ohm and 8 ohm in series means it is basically 10 ohm, and 10 and this together, if you add both of them, so 12 by 5 plus 10, guys. So this will be nothing but, 12 plus 10 5s are 50 divided by 5. Definitely it is not equal to this. Definitely it is not equal to this. Okay, we can choose some random option then. Some of you are saying D. Okay, we can try that out. 2 and 4 are in parallel. So if 2 and 4 are in parallel, it will become 2 into 4 divided by 2 plus 4, which is nothing but 8 by 6, which is nothing but 4 by 3 are in parallel. 6 and 8 ohms are in series, so it will be basically 14 ohms. 6 plus 8 is 14. Now you just have to add them, guys. You just have to add them. Yep. So 4 by 3 plus are in parallel with 6 and 8 ohm in series. Connect these resistors so as to, okay, what is it? Plus 14, guys. Yes, just check this out. 4 plus 14 multiplied by 3, which is nothing but 42 divided by 3. Yes, so this is nothing but 46 divided by 3. Exactly what we wanted. Yes, perfect. So D is the correct option. D is the correct option. So these kind of questions usually consume a lot of time because you have no other way to do it other than that. Okay, makes sense? Cool. Shall we go ahead, guys, to the next set of questions coming up on your screen? Okay, combination of cells. This kind of questions, when they come, lot of students forget the formulas. See, whenever you have cells, batteries in series, the equivalent effective resistance, internal resistance will be just like in series, R1 plus R2 plus Rn. Equivalent EMF, effective EMF is also E1 plus E2 plus En, all the batteries EMFs combined together. But when it is in parallel, then be careful. When it is in parallel like this, then be little careful. Yeah, for effective resistance, same like resistors in parallel, 1 by R1, 1 by R2, like that. But for effective EMF, here is the formula. Observe it carefully. It is EMF 1 by R1 plus EMF 2 by R2, like that EMF n by Rn, the whole thing divided by 1 by R1 plus 1 by R2, like that 1 by Rn. So that is the formula for effective EMF of parallel batteries besides each other. Okay. If you have unbalanced bridge, please leave that question. It is a wastage of time in VITEEE EEE because that will take Kirchhoff's voltage law and Kirchhoff's current law to solve the problem properly. So if you can eliminate the options, like some options, this current can't happen because whatever the voltages are known, resistances approximately you can make out, it can't go beyond this. So quickly eliminate certain options, and if you can narrow down to 2 options, take a guess. Otherwise leave such a question. It is not worthy to be solved at that point of time, and all questions won't be difficult. Okay, cool. So let's have a look. 24 batteries, EMF 1.5 volts, each having internal resistance of 1 ohm, are connected to an external resistance of 1.5 ohm. question is to get maximum current. I think there is no other option. Just like the previous problem, this is also trial and error. So ideally in the exam, I will leave this to the end. When I'm not able to do anything else, I will try this question. But this is a lengthy question, guys. Check this out. 24 cells, each of 1.5 volt. So just take this, let's say example A. So imagine like this, 24 cells are there. 24 cells are there, and they are connected to an external resistance of 1.5 ohm. So what is the effective EMF that you will get? Each battery is 1.5, 1.5, 1.5, 1.5, like that 24 times, isn't it? Everybody with me? Devil FC Gaming example exactly I'm giving you. Exactly that same example only I'm giving you. Okay. Yes. Okay. So 24 into 1.5. 1.5 is 3 by 2. 24 by 2 is 12. 12 threes are 36. So 36 volts. And what about the effective resistance, guys? It will be 1 ohm. Like that, there are 24 cells. So it will be 24 ohm. So what will be the current in this case? Current will be total EMF, which is 36 by total resistance, which is 24 plus 1.5. Okay, so that will be 36 divided by 1.5, 24.5, that is 25.5. Okay, so let me just keep it like this, 36 by 25.5. I will not do anything with it. Then imagine if they are in parallel, then what will happen if all of them are in parallel? Imagine now all these batteries are in parallel. Okay, all these 24 batteries, and then they are connected to this external resistance of 1.5 ohm. What will be the effective EMF? Try this out. E1 is 1.5, resistance 1 is 1. Like that, you will get 24 terms. 1.5 by 1, 24 terms. Again, 1 by R1 plus 1 by R2, like that, 24 times you will get it. 24 times you will get it. So this is 1.5 by 1 into 24 divided by 1 by 1 into 24. 24, 24 cancels. I'll be just left with 1.5 volt. Is that right? I'll be just left with 1.5 volt. Yes or no? Okay. All right. Now, what do? Find the equivalent resistance, effective resistance. Whatever internal resistance is there, divided by 24. Okay, because they are in parallel, right? So 1 ohm by 24 will be the effective resistance in parallel. So what will be the current in this case? EMF, which is 1.5, whole thing divided by resistance, which is 1.5 ohms plus 1 by 24. I think this is definitely going to be less current, but the question is maximum. So B option is eliminated. Same thing you do it with this also, either C and D. You can try any one of them. Let's say, for example, you try D option or C option, whatever. 6 cells in each row connected in series, 4 such rows are connected in parallel. Chumma. Okay, 6 cells in each row. If you have 6 cells in each row and you have 4 such rows, and you have 4 such rows, tell me one thing. Each row that is there, 6 batteries are there. The voltage will be 1.5 multiplied by 6, correct? 1.5 multiplied by 6, which is basically 9 volts. And the resistance will be 1 ohm each of 6 resistances. So 6 ohm. Like that, they are in parallel. So imagine batteries of this 9 volts and 6 ohms, and then they are in parallel. Do you understand the length of this problem, guys? So that is why I told you, you will leave this question in the exam. But I'm just telling you, if there was a simpler version, how you would do it. Now, each of them are in parallel. So effective resistance is 6 divided by 4 such rows are there. So by 4. So that will be 3 by 2 ohm. And battery EMF. Well, EMF will still be 9. Whenever you are in parallel and equal EMFs are there, it will still be the same. But if you want to see the formula, it will be like this. 9 by 6 plus 9 by 6, 4 times, and 1 by 6, 1 by 6, 4 times 4, 4, 6, 6 cancels, you will still get it as 9 volts. Now, this particular circuit is connected to a resistance from outside of 1.5 ohms. So find that current. Total voltage is 9 volt divided by total resistance is 1.5 plus that 3 by 2. Now compare all the currents from D option, C option, A option. One of them will be maximum. The answer comes out to be D in this case. Got it? How this has to be solved? Pakka? Yeah. The English session is going to be conducted in 2 days. Yeah. All right. We have UGEE sessions also lined up. That's the reason for that. Magnetic effects of current, Biot-Savart's law, guys. Let's quickly go through it. Magnetic field due to a current carrying element mu naught by 4 pi IDL sine theta divided by r square. That is the formula. Mu naught by 4 pi is your constant, 10 to the power minus 7. I is the current, dl is the element due to which you are finding the magnetic field, which is dB. Sine theta is the angle at which you are finding the magnetic field. R is basically the distance from it. You get some basic formulas. First is due to a long wire, the magnetic field is given by magnetic field due to a long wire carrying current is mu naught I divided by 2 pi r. Then due to a circular loop carrying current on the axis, the magnetic field is given by mu naught I r square divided by 2 r square plus x square raised to 3 by 2. Very, very important, guys. These two formulas are very frequently asked. If there are n turns, you multiply by n. If there is an arc, you take the fraction of that arc. You do not take the whole loop. So if it is 1/4 of the loop, then you multiply it by 1/4. If it is semicircle, you multiply it by half. So depending on how much part of that loop is considered, you multiply it with such a fraction. If an arc type of diagram is there, questions like this might come. So you just need to see how much angle is made accordingly. That much, 1/5, 2/6, whatever that number will come. So there is an element which is placed at the origin and it carries some current. The distance of 1 meter, what is the value of magnetic field? This is direct Biot-Savart's law. Yeah, mu naught value 4 pi 10 to the power minus 7. Mu naught by 4 pi is 10 to the power minus 7, right? So directly you can write mu naught is equal to 4 pi 10 to the power minus 7. Is that okay? SS, can you please do Manipal session? Moon live vibes, please leave a comment after the session is over. I will see the number of likes on that comment and decide. Okay, cool. Coming up on the screen, here it is. What do? Magnetic field is mu naught by 4 pi IDL sine theta divided by r square, 10 to the power minus 7. Current, how much is the current? Where is it? 10 ampere. The length of this element is nothing but 0.05. Okay, this is basically r, this is basically dl, this is basically theta, which in this case is 90. So when theta is 90 degree, sine 90 is 1. Okay, divided by r square, r is the distance. How far is it? 1 meter. So this is 1 meter. That's it. So answer should contain 5 in the answer. Yep. So it can't be 4.5, 5.5, 7.5, because do you see the number 5 decimals, zeros, etc.? So it can't contain anything else. It has to be a power of 5. So 5 10 to the power minus 8. Option C, very good. Venkata, Shirish, Shweta, motivational, awesome. What about others, guys? Gave up so easily. Direct question. Next, magnetic field due to straight wire carrying current of 12 amperes at a distance of 8 centimeters. This was VITEEE 2021 question. Let's solve this. So magnetic field due to the wire, I just give the formula mu naught I divided by 2 pi r. So mu naught is 4 pi 10 to the power minus 7. Current 12. This 2 pi is there as it is. Okay. Distance is how much? 8 centimeter. So that is basically 8 into 10 to the power minus 2. Okay, so you can cancel a lot of things. I can already see it. Like, see guys, over here, this will go with this, 2 will go with 8 4 times, 4 will go with 12 3 times. So pi also cancels. So 3 will be there in the answer. So there is only one option with the number 3. So there is only one answer with the number 3. So B is the correct answer. Ignore the powers of 10, decimal places and zeros. Yeah, directly you can give it. You don't have to sit and calculate all those things. Make sense? Okay. Let's go. Next question on your screen now. Force due to two parallel wires. Yes. If the wires are carrying currents in the parallel direction versus anti-parallel direction, well, if they are in the parallel direction, they will same current, so they will attract each other. They will attract, and if they are opposite currents, then they will repel each other. That force per unit length, that force per unit length is given by mu naught current 1, current 2 divided by 2 pi into distance of separation. Also remember, whenever you have a wire which carries current, the force on that wire due to the magnetic field is IL cross B. IL cross B is the force on a wire carrying current due to an external magnetic field. So using that only you get this formula, but this is, remember, force per unit length. Let's go to the question coming up on your screen. The question says there are two parallel conductors. They are carrying currents in the opposite directions. One conductor 20, okay, and okay. A point C is at a distance of d by 2 to the right of the 20 ampere current. If D is 18 centimeter and I is adjusted so that the magnetic field at C is 0, then the value of the current is how much? Okay. So we want the magnetic field at C to be 0. Because of this 20 ampere current, if you hold the thumb in this direction, the field lines are going inside. Okay. And this is at a distance of how much they have given? D by 2, if I'm not wrong. Yes, this is basically D by 2. So the magnetic field inside will be mu naught I divided by 2 pi R. R is the distance, which is D by 2. Now consider this particular current. Hold your thumb downwards, then you will see the magnetic field is going like that and going inside here. So from behind it will come in the front. So it is coming this way. So that particular magnetic field will be mu naught, current I do not know, divided by 2 pi. Guess what this distance would be? Guess what this particular distance will be? 3d by 2. D plus d by 2 is 3d by 2. So 2 pi into 3d by 2. Because we want the net adjusted so that the magnetic field at C is 0. So these two, outside and inside, should cancel, balance each other out. So the moment they balance, cancel each other out, mu naught by 2 pi and D and 2 will cancel out each other. And let's see what is left with us. We have I divided by 3 is 20. So I is basically 60 amperes. So 60 amperes is option B. Directly you can get it. Beautiful. Yep. If the question was, will they attract or repel each other? Will those wires attract or repel each other? Then the answer will be, because they're opposites, so they will repel each other. Great. Very good. Yeah. Ordinary person, you'll be getting the PDF. Don't worry. Moving on to the next question, solenoid. Solenoid formula, my dear students. Magnetic field inside a solenoid is mu naught Ni. This is total turns per unit length. Total number of turns per unit length. This is magnetic field inside a solenoid. The magnetic field outside the solenoid is approximately 0, negligible. It is not there. Moving on to some question. Magnetic field on the axis of a solenoid having 5 turns per centimeter length when this much current. 5 turns per centimeter. 5 turns per centimeter. A centimeter is 10 to the power minus 2 meter. So this will become 500 per meter. That is the number of turns per unit length. So if it is per centimeter, if you multiply by 100, you will get it per meter. So question is, find the magnetic field. Magnetic field is mu naught Ni. Mu naught is 4 pi 10 to the power minus 7. Number of turns per unit length is 500. Current is 0.8, I believe. Okay, 8 5s are 40. The decimal will go. It will become 4. 4 4s are 16. So 16 pi. 2 zeros and 10 to the power minus 7 will make it 10 to the power minus 5. So 16 pi 10 to the power minus 5 should be there. Just check this out. 16 pi. So where is it? Where is it? 16 pi will not cancel then. Pi turns per centimeter. I think there is some mistake in the powers. What have they given? Just check, guys. 16 threes are 48. So close to like 50 you will get. But approximately we will get this as 16 threes are 50. Have I missed any number? Just check this out. This decimal 5 into 8 5s are 40. 0 and decimal went away. 4 4s are 16. Okay, pi is there. And these two zeros with this minus 7 will make it minus 5. So it will become 50 into 10 to the power minus 5, which is 5 into 10 to the power minus 6. Just check this out. Uh, so that is what I'm getting. 5 into 10 to the power minus 6. Yep. Maybe the powers of 10 have been made printed wrong or something. So I think it could have been minus 6, but it was printed as minus 8. So otherwise, this is the answer. Tesla or Weber per meter square is one and the same unit. Yeah. So approximately it will be 50. So 50 is close enough to 5. 50 is close enough to 5. So option A, guys. Moving on to the next question. Yes, coming to EMI. Ready for EMI? Okay, let's go. Let's go. Inductors. Inductors, self-inductance property. Yep, the flux through an inductor is L into I. And if you use Faraday's law, which is minus d phi by dt, it will be minus L di by dt, which is the induced EMF inside an inductor. All right. Thank you so much, Velvet Whisper. Yes, the questions are very much similar, but I would still suggest solve a few papers of Manipal. That will be good enough, okay, for you. Don't have to waste too much time on Manipal. Just solve few PYQs of Manipal entrance tests. All right, come on, let's go, guys. Next, inductor's energy stored inside an inductor is half Li square. Inductors in series behave like resistors, so it will be L1 plus L2, but inductors when in parallel, it will be 1 just like resistors, 1 by L1 plus 1 by L2. Lastly, inductance of a solenoid is mu naught n square A L. That is the formula for inductance of a solenoid. Inductance of a solenoid. These are the major things. And if you have mutual inductance, the formulas are also again similar. Mutual inductance is M. So flux through the secondary is mutual inductance into current through the primary, and EMF in the secondary is negative M di1, rate of change of current in the primary. So this also many times you might be using it. Okay, cool. So let's have a look at some question. The induced EMF in some inductor changes from this to this in 0.2 second. So what is the EMF? Oh, directly they have asked the EMF. I mean, like this formula, minus L di by dt. I'm just interested in the magnitude. So it will be L, total change in the current upon total time. So inductance, how much? 10. Change in the current, directly go 9 amperes to 4 amperes. Just take the mod value. 9 minus 4. Time interval 0.2. So 10 multiplied by 9 minus 4 is 5. 5 divided by 0.2. 0.2 is nothing but 1 by 5. So it will become 10 multiplied by 25, which is nothing but 250 volts. So 250 volts is option B. Yes, that is the correct answer. Correct? Yep, very good. Awesome, awesome. Majority of the questions you will see will be from 12th standard. That's what we have seen. That's why I have taken high weightage topics. So yes, there are some 11th standard topics like thermodynamics, thermal physics and all of that, which are generally asked in your VITEEE EEE. So these are your high weightage topics, whatever I'm doing today. Motional EMF. If you move a conductor inside a magnetic field, then you will see EMF is developed across that conductor. across that conductor, that motional EMF is magnetic field into length into V. But if that same conductor is held like this and moved like this inside the magnetic field, then the EMF is 0. Or even if the conductor is like this and let's say the velocity is same as the direction of the magnetic field, then also the EMF is 0. So all of them have to be perpendicular, the length, the velocity and the magnetic field. All of them, when they are perpendicular, only then the EMF is developed, else you will see that the EMFs become 0. Okay. And one more thing over here, if you take a rod and you rotate it inside a magnetic field, the EMF developed is half B omega L square. If you rotate it with some angular speed, half B omega L square. Let's say a conductor is moved parallel to itself with a speed of 2 perpendicular to the magnetic field. The induced EMF is how much? Come on guys, directly everything is perpendicular, so EMF will be nothing but, so what is this, BL into V. Magnetic field 10 to the power minus 3, length 5 centimeters, so 5 into 10 to the power minus 2, velocity 2. 2 5s are 10, so answer will be 1 into something, but we have to do it. So 10 to the power minus 3 minus 2 will become minus 5. 5 2s are 10, so this will become 10 to the power minus 4 volt. 10 to the power minus 4 is C option. Yes, it is correct. C option, minus 4. Very good, Sweta. Awesome. Okay. In mechanics point of view, just do work power energy. Yeah, work power energy. A little bit of kinematics. A little bit of kinematics. Main rotational formulas and some bit of rotational, I told, some bit of SHM, simple harmonic motion. That's all. So these are the major topics which you might be asked. And yeah, of course, center of mass. How can I forget? Center of mass. So if you do this much, it's good enough. You can leave off relative motion, vectors. Uh, you can also skip a little bit of friction, this, that, circular motion, all these things. That's okay. Units and dimensions, sometimes they might ask, sometimes they might not ask. It's all very vague. And most of the private college entrance exams, it's very unpredictable at times. Just at least NTA was little bit unpredictable, but trust me, all these entrance tests are very unpredictable. Suddenly they increase the level, suddenly they decrease and make it very easy. It's all complete luck. And the admission process is also not very transparent, I would say. So I would say, please, if you get any of these colleges, make sure that you are getting it in the first 1 or 2 rounds maximum. Do not pay unnecessary fees and go to a lower branch. That is something which I would definitely not advise. Rather, better take a drop and then go for even a normal government college rather than taking a random stupid branch, and that to paying donation fees, this fees, that fees, wasting your parents' money. Better to take at least a drop and prepare properly for some better college next year. Okay, so be careful about it. Okay, going to the next question. Transformers, primary turns by secondary turns is primary voltage by secondary voltage, which is secondary current by primary current. This is assuming 100% efficiency. Remember, we assume input power is output power, 100% efficiency, and power is nothing but V1 I1, and this is nothing but V2 I2. Yes, input power and output power, we generally assume it to be equal because of 100% efficiency. If it is not, then you take, okay, output power is 20% less, 30% less, whatever it is. A transformer has some windings here and there, primary, secondary. AC voltage of primary, okay, is given, current is also given, the voltage across the secondary and the current in it. Okay, direct formula, guys. So N1 is nothing but 400 in the primary. Sorry, not 400. How much is it? Primary is 200. So 200 in the primary, 400 in the secondary. N1 by N2 is V1. Is V1 given? 110 volts is connected to the primary. So 110. Secondary voltage, I do not know. Here you will get I2 by I1. Current 1 is basically 10. Solve this, you will get the answer. So V2 will be 110 multiplied by 400 divided by 200, and I2 will be just multiplied by 10. So 200 multiplied by 10 divided by 400. So this is half. So 10 by 2, which is nothing but 5 amperes. And this is 2. So this will be 220 volts. So 220 volts and 5 amperes, which is the D option. Is that right? So directly you can get it using the transformers formula. Very good, very good, very good. Excellent. Moving on to the next question. Peak RMS values of current and voltage in AC circuits. Okay. So usually your AC voltage is generally like V naught sine, let's say omega t plus phi, and your current might be like I naught sine omega t, where phi is the phase difference. Then the RMS voltage, V naught is the peak voltage. RMS voltage is V naught by root 2. Average voltage is obviously 0. RMS current is again I naught, peak current by root 2, and average current is obviously going to be 0. Next thing, power on an average is not 0, obviously. It is going to be VRMS into IRMS into cos of phi, that same phase difference between voltage and current. Yeah, this is the formula. And that omega is your angular frequency, keep that in mind. And that is nothing but 2 pi f, which is also 1 by, sorry, which is 2 pi, frequency is 1 by time period. If you ask me what is this particular V naught, this V naught in AC generation is magnetic field into area of the coil into angular frequency or angular speed into number of turns. This is from how you generate AC generation. AC generation. Born is the maximum voltage which is generated across an AC generator. So in a AC generator, a coil of area A n turns rotates with a constant speed, generating this much voltage, AC voltage. Cool. So let's do this particular question, my dear students. Observe. Alternating current is 50 sine 314t, the peak value and the frequency of the current. Come on, this is very direct. What is the peak value of the current? Peak value is obviously 50. So that is basically your I naught. So 50 is there here and here. Now the next part is frequency. So omega is this one, 314, and omega is 2 pi f. 314 is 3.14 multiplied by 100. 3.14 is basically pi. So 2 pi f, and this is nothing but 100. Pi goes. So frequency is 100 by 2, which is basically 50 hertz. So 50 hertz is over here. So B option is the right answer. Is that right? Clear? Everybody with me? Very good. Very good. Very good. Excellent, guys. Keep it up. Keep it up. All right. All right. All right. Let's go. Let's go. Let's go. Let's go. Let's go. Let's go to the next question coming up on your screen. Reactances and impedance. Yes, reactance formula. For inductor, it is omega L. For capacitor, it is omega C. And the total impedance of the circuit is given by resistance square plus XL minus XC whole square. Also keep in mind that voltage across inductor is current into XL, voltage across capacitor is current into XC, voltage across resistor is current into resistance, and the total voltage is the total current into the total impedance. All these formulas you should definitely know. Okay. Cheat codes for VITEEE, just search over here on our channel only. VITEEE cheat codes. You will get it. Okay. So just check this video out. Last year I have made this video. Okay. So luckily I did not delete it because nobody had any problems with it. So please check that cheat code video out. It's there on the channel only. Right? Cool. Right. Let's move to the questions, guys. There is a AC signal which is applied to the circuit of some inductance. Okay, perfect. And resistance, the impedance by the circuit is. First of all, find XL, which is nothing but omega L. Omega is 2 pi f into L. So 2 pi f, frequency is 50. Inductance is 1 by pi. Pi goes. So this will become 100. So 2 into 50 is nothing but 100. Is that right? Now you have to find the impedance. Impedance is R square plus XL minus XC whole square. XC is not there only. resistance is there, which is 2100. XL is 100, and nothing is there apart from that. That's it. So what will you do in this case? Obviously, the answer for this particular problem will be more than 2100. So this is eliminated, this is eliminated, but it can't go to 2500. I mean, this number 100 is very small as compared to 2100. So I think it will be option C without even having to calculate it. Yes, it is option C. Got it? Why it is option C, guys? Yeah, we don't need the value of the exact root. We don't have to. Just use your brains, common sense. This is 2100 square under the root. So obviously answer will be more than 2100. This is eliminated. It can't go to 2500 because 100 is very small as compared to 2100. Got it? Yep. Very good. Awesomeness. Perfect. Let's go to the next question. In the given circuit, what's the current through the resistor? XL, XC and resistance. Everything is given. RMS voltage is also given. First thing, find the impedance directly. Z is root of R square, which is nothing but 100 square plus XL minus XC, which is 200 minus 100 whole square. So it will be 100 square plus 100 square. So 100 is common and root 2 ohms. So that is your impedance. Now VRMS total is the total RMS current multiplied by the total impedance. VRMS is 200 root 2. Current I don't know. IRMS is 100 root 2. Root 2 goes 0, 0, 0, 0 goes. So IRMS will be obviously 2 amperes. So 2 amperes is over here, option A. Perfect. Answer A is the correct answer. Correct? Everybody with me on this? Excelente, excelente, excelente. Let's go to the next question. Ray optics. What are the common topics that they have been asking? Power of a lens. Yes, they usually ask this kind of questions. So power of a lens is 1 by the focal length, which is also refractive index of the lens by refractive index of the medium minus 1 by radius of one curvature, radius of second curvature for that lens. This is generally the power of a lens. But whenever you have lenses in contact, then the effective power is P1 plus P2 plus Pn, and 1 by the effective focal length is 1 by F1 plus like that till 1 by Fn, and the effective magnification is M1 multiplied by M2 multiplied by like that nth magnification. Also keep in mind, if you have a lens like this and somebody breaks it into two parts, so one part is here and the other part is here, nothing changes for this lens. So if the original lens had power P, then each of this part will also have the same power P, only the brightness or intensity will reduce. But on the other hand, if this particular lens was like this and you break it into two parts over here, one like this and one like this, each part will be P by 2 power. Each part will be P by 2 power if the original lens had power of P. Keep this in mind. Very, very important concepts. Wow, the first problem is only that. Okay, so quickly guess the answer. So the original lens had a power P. L1, L, this is L1, this is L2, this is L3. So whose power? Choose the incorrect option they have told. Choose the incorrect option. Resonance frequency is 1 by root LC. 1 by root, yeah. Omega, where did it go? Where did I write it? If that kind of resonance kind of concept is asked, so natural frequency for resonance is 1 over root LC. This is for resonance, where XL will be equal to XC and the impedance will be only the resistance. So that is what will happen, and current will be maximum and the impedance will be minimum. That is what happens. Okay. Come on, guys. What is the correct answer for this? Power of original lens was P. So when you break it into two parts, this will be P by 2, this will be P by 2. This part will still have power P. So L1 will be P by 2. That is 100% wrong. L2 will be P by 2, L3 will be P by 2, L1 will be P. Perfect. So this is correct, this is correct, this is correct. But the question is which is incorrect? Which is incorrect? So option A is incorrect. Yes, perfect. Very good. Venkata, Vedashree, Zeba. Yes, Dakshin. Awesome, Virat. Awesome, Shweta. Yes. But I hope you also saw that there were some questions which are also difficult. And what will you do when you get a difficult question? Very difficult question. Leave it and come back to it later on. Please keep in mind there will be 100% some difficult questions, and you're not expected to solve all the difficult questions. No, definitely not. Because even if you miss few questions, still you will be in the top ranks. Keep that in mind. Okay. All right. Prism related questions. Prism related questions. Let's do it, guys. A given ray of light suffers minimum deviation in an equilateral prism. Okay. Additional prism Q and R are placed of identical shape materials. So now the ray will suffer. Oh, it is equal, no? So the ray will go like this. It will go like this. So it is like a glass slab, guys. I mean, this is the same medium. So earlier, what used to happen was the ray was going like this. See, I'll tell you what. Earlier, this ray went like that, then went like this, and then went like that. Earlier. Now, what will happen? Because it's the same material, no change in medium, no change in medium. So, what will happen? Whatever the ray will come over here, that ray will continue to go like this, and eventually it will come out like that, and these two will be obviously parallel to each other as compared to the previous one. Instead of coming out from here, now it will come from here. Obviously they are going to be parallel to each other, so deviation will be the same. So I think same deviation as before, that is the correct answer. So earlier this was the deviation, now this is the deviation, which is obviously going to be the same. It's a very direct question, no need of any formulas or anything else. Moving on to the next question coming up on your screen. The refractive index of a prism with the apex angle A is cot A by 2. Oh, this was also asked in JEE. If you remember, JEE asked this and VITEEE asked it. So, in fact, last year only, JEE asked this same question 2 times in 2 different shifts. And VITEEE had the same question. What does this tell you? Those people are also little bit lazy. They want to pick up the same question. So good thing for you. So if you have attended all the discussion sessions, 100% you will find some repetitions. Similar models will definitely get repeated from JEE in VITEEE. This was a JEE question, if you remember. Okay, so what is this? Apex angle is refractive index. Okay, angle of minimum deviation. There is a formula, mu is equal to sine of A plus delta minimum by 2 by sine of A by 2. So mu is already given to be cot of A by 2, and this is sine of A plus delta minimum by 2, and this is sine of A by 2. Now cot is nothing but cos divided by sine. So what happens is when you write that, this sine and this sine will get cancelled off. Cos by sine, sine A by 2, sine A by 2 will cancel. So this will become cos A by 2 is sine A plus delta minimum by 2. So cos I can write it as sine of 90 degree minus A by 2. Cos theta is sine 90 minus theta. That's all. So that I can easily compare them. So A plus delta minimum by 2. Now whatever is there inside should match. Therefore 90 minus A by 2 will be A plus delta minimum by 2 multiply by 2. So 180 minus A is equal to A plus delta minimum, and there was delta minimum. So delta minimum will be 180 minus 2A. A goes on this side minus 2A. So option D is the right answer. Yes, very good, Pranav, Sugant, Shirish. Great. It looks like you know it from the J1. Yeah. I think everybody knows Jarvis about it. Nothing new. Okay. So that's why I said I cannot say it out in the open. So please make sure that you are very careful when you are applying and choosing the branches and in which round and which college, which fees, how many fees. what you are doing, everything you should be aware of, financial condition. So be careful. Okay, everybody knows about it. All right. Moving on, guys. Shall we go ahead to the next question? Shall we go ahead to the next question? Coming up on your screen. YDSC related question. Let's do it. Okay, let's speed up the process now. In YDSC, how many maximas can be obtained on a screen, including the central maxima on both sides of the central maxima, if lambda is this much and d is this much? For these type of problems, I'll tell you what is the simple trick. Just find out the value of lambda by d, how much it is. It's 3000 by 5000. Okay, 0 cancels, so this will be 3 by 5 is lambda by d. So d is basically 5 by 3 times of lambda, which is basically approximately 1.67 lambda. Is that right? That is what d is. So first step, find d. Now imagine this is your screen, this is the center. At the center, the path difference is 0 lambda. The next maxima will be when the path difference is 1 lambda. Next is 2 lambda, 3 lambda. Like that, excuse me, n lambda. Down also path difference 1 lambda, 2 lambda, 3 lambda, n lambda. You will get maximas. These are all maximas. So the path difference of the maximas is integral multiples of lambda. Okay, very good. Awesome. Oh, first time here. Welcome. Okay. Need more classes? Yes, Sivaram, what to do, man? We are doing everything that we can. Every day we are coming here, giving you some or the other content. Yeah, just yesterday we gave you for KCT. Before that, J Advance is also there. Tomorrow, UGEE is also there. And again, after that, we are coming for VITEEE and then J Advance. Everything is coming up. Whatever we can do, we'll do. Okay. Now, what to do? See, D is 1.67 lambda, no? So your path difference always has to be lesser than D. That means always lesser than 1.67 lambda. So where is 1.67? Where is 1.67 number? Somewhere here, somewhere here. So only these many will be visible. These many will be visible. 1 and 2. In between that, you will have 1.67. So 1, 2, 3. So answer is 3, not 5. Sorry, this is basically 5. How many maximas can be obtained? The answer is going to be basically 3. Is this absolutely clear, my dear students? Perfect. Okay, very good. Classes for EAP SAT? Yes, please let me know if you want those classes in the comments, and I want you to like those comments. All the Andhra Telangana students, like CND. Yes, make that comments, make those comments and like CND. Yes, yes. Great. Moving on to the next question, guys. Coming up on your screen. Two light beams, intensities are in the ratio 9:4 are allowed to interfere. The ratio of the intensity of maxima and minima will be ratio of intensity of maxima and minima. Maxima intensity and minima intensity ratio they have asked. Well, I know one thing. Maximum intensity has a formula root I1 plus root I2 square. Minimum intensity has a formula root I1 minus root I2 square. Now the original intensities are 9:4. So let's take it as 9i and 4i for simplicity's sake. So this will become root 9 of I plus root 4 of I square divided by root 9i minus root 4i square. So root 9 is basically how much? 3. So 3 root I plus root 4 is 2. So 2 root I. And here we have again 3 root of I, and here we have 2 root of I square. 3 plus 2 is 5. So we'll have 5 root I. Okay. And the bottom 3 minus 2 is 1. So 1 root I will cancel. So 5 square, which is 25 by 1. So 25 is to 1, which is the D option. That is the correct answer. So if you know this formula, it is easy. If you know the maximum and minimum intensity formula, it becomes definitely easy. Cool. Shall we go ahead to the next question coming up on your screen? Let's go to dual nature related de Broglie wavelength. De Broglie wavelength related concept. De Broglie wavelength of a proton and alpha particle are equal. Ratio of their velocities are. Okay. What's the formula for de Broglie wavelength? Concept is lambda is h by momentum. Momentum is mass into velocity. So de Broglie wavelength of proton and alpha are equal. That means h by mass of proton into velocity of proton is h by mass of alpha and velocity of alpha. H cancels. So this is how it is. So we all know that the mass of alpha particle is 4 times the mass of a proton, because two protons, two neutrons, approximately neutron and proton have the same mass. So MP and MP will cancel. And what have they asked? The ratio of their velocities. So VP by V alpha will be 4:1. Will be 4:1. VP by V alpha is 4:1, which is option B. Perfect. There we go. Hi, Crack J. Welcome aboard, everyone. Let's go to the next question coming up on your screen. Photoelectric effect related concept and question. There are two lights. First light has a wavelength double of the second wavelength, and they are falling on the same kind of plate. The maximum energy is K and KB. Compare those kinetic energies. Photoelectric equation, that's all. So we know energy of the photon is work function plus kinetic energy. So 2 times, let's write it down. Energy of the photon, first case, is hc by 2 lambda. Why 2 lambda? Because lambda is 2 times of lambda b, and that is work function, which is going to be the same, plus kinetic energy A. Next time, the wavelength is just lambda. For B, it is just lambda B. Work function is phi, kinetic energy is KB. Let's now think what to do. We have been asked the comparison. Okay, so what will be Ka? What will be Ka from here? Ka will be Hc divided by 2 lambda minus phi. And what is Kb? What is Kb? It is Hc by lambda minus 5. So is Ka equal to 2 Kb? Definitely not. If you multiply it 2 times, you definitely do not get this. Is 2 Ka equal to Kb? If you multiply this 2 times, you will definitely not Kb. So obviously B option is eliminated, C option is eliminated. It is directly seen. Now who is more and who is less? That is the only thing. So K is less than Kb by 2. So if I do Kb by 2, let's see what do we get. Kb by 2 is Hc by 2 lambda minus phi by 2. As you can notice, this term is same, but this is more, phi is more as compared to phi by 2, which is less. So if you take away lesser quantity, this number will be more. This number will be more. You are subtracting a smaller number. Here, you are subtracting a bigger number from it. So obviously this will be less. So Ka will be less than Kb by 2, which is obviously option A. So option A is the right answer. Very good. Very good, Sweta, Shubham, Zeba, Riyansh, Pranav, Akhil. Did you make a mistake? Yes, Venkata. Perfecto. Shall we go ahead to the next question on your screen? Thermodynamic gas loss. Wow, what a question. Internal energy versus density graph is given for a monoatomic gas. The corresponding variation of the pressure with volume is best represented by. Let's see how many of you get this. Crack this question, then I will accept that you are going to nail the VITEEE exam. Come on, guys. Why not D? Because I just got K is less, not more. I just got K is less than Kb by 2. So K is less than Kb by 2. If you do 2 Kb also, you will see that it will not match. I mean, and anyways, if one option matches, everything else have to be wrong. So you can try it out. 2 times Kb, if you try to do 2 times Kb, it will not make sense. It will definitely not be less than K and all of that. You cannot conclude all those things. Okay. Anyways, coming back to this question. Some of you are saying A. Come on, my dear students. What is this? Need a roadmap for JEE 2026? Definitely. Definitely in INOS. I know you guys are waiting for that. Okay. So how to solve this problem? Internal energy versus density. I know internal energy is NCVT. Number of moles is 1. Monoatomic means R by 2 and temperature. So if internal energy versus density graph is a rectangular hyperbola, that means internal energy is inversely proportional to density, or this is inversely proportional to density, or I can say that the temperature is inversely proportional to density. But we all know pressure into molecular mass is rho RT. So over here, it is very obvious that density is inversely proportional to temperature if pressure is a constant, because M is a constant anyways, R is a constant. So their product is a constant. That means they are inversely related to each other. So only if pressure is constant. So pressure is constant here also and here also. I think both the options by mistakenly they have printed the same. Maybe I think something was different, but I think printing mistake is there. So D option or B option both are same right now. Is that clear, everyone? जे मीन्स का रिजल्ट आ जाएगा क्या पता नहीं, आ भी सकता है नहीं भी आ सकता है, पता नहीं. Cool. So we'll see, guys. Let's go to the next question. Thermodynamic process related. My dear students, the question says the cyclic process for a 1 mole of ideal gas is shown. Volume temperature diagram is given. The work done in AB, BC, CA. My God, all the things they have asked. All the things they have asked. In all the three processes, what is the work done? I feel there is one process which can give me the answer easily, and that is AB. For AB process, it is isochoric, and in isochoric process, the work done is always 0. So A to B is the first line. So 0, 0 and 0. So B option is definitely not going to be correct. Is this absolutely clear? Okay. Next, BC is isothermal, so that's why logarithms are there. Okay, fair enough. CA, CA is nothing but isobaric process. C to A, C to A is definitely isobaric process, and work done from C to A is P delta V, which is also NR delta T. Number of moles 1, R is R, delta T is final minus initial. So T1 minus T2. So T1 minus T2, T1 minus T2, it is there over here for C to A. No need to check any other option. C option is the right answer. It will be correct even if you do it for this guy, which is isothermal. Isothermal. So work done from B to C is nRT log of V final volume by initial volume. So N is basically 1. So 1 RT, T is basically your temperature T2. So this is basically T2. This was 1 mole, it was already given. Okay, log of final volume by initial volume. So that is also matching. So yes, option C is the most appropriate answer. Yep, very good. Are you guys enjoying the session or no? Or chumma just watching without liking the video? Yes, sir, we just watch, we don't care. It's okay, you struggle, your voice goes, you stand, your leg pains. Sir, you do this for free, we don't care. Sir, this is South Indian channel. No, sir, it's okay, fine. Other students, so many channels are there, Hindi channels, they show all their love, but we don't care. We are like, okay, fine, sir is coming, teaching, no problem, because there is only one or two channels, maybe three channels. I don't know how many channels are there who are working hard. Yes, we have Tamil channel, we have Telugu channel, the only national channel at a national level for all the students in South India, or all the students on English medium, all the students in English medium, no matter where you are, which part of the country, only one channel, guys. You have to show your support. This love should be there. Tell your juniors about this, and we give quality content. Please smash that like button. Okay, thank you so much. And if you are watching it as recorded, please yeah, leave a comment. And even you guys, after the live is over, please make sure that you leave a comment. Yeah, great. Thank you so much, Devil. Okay, great, great. Okay, so moving on to the next question coming up on your screen. What do we have? The ratio of the minimum wavelength of the Balmer and Paschen series of hydrogen. Balmer and Paschen. Minimum wavelength means energy difference is maximum. So maximum transition, Lyman Balmer. Balmer is 2. So 2 and infinity. 2 and infinity will be the transition. Paschen series is 3 and infinity. Yes, that is what the transition is. And the formula that you will be using, 1 by lambda Rydberg constant, 1 by n1 square, 1 by n2 square. Is that right? So 1 by lambda of Balmer, 1 by lambda of Paschen. R is going to be the same anyways, 1 by 2 square minus 1 by infinity square. Here also R, 1 by 3 square minus 1 by infinity square. R will cancel. 1 by 2 square is 1 by 4. Infinity's reciprocal is 0. This is 1 by 9. 1 by infinity is a large number. So large number, if you take the reciprocal, so it will be 0. So that's why 0 is here. So this will become 9 by 4. This will become lambda p by lambda b. This will go on the top, this will come below. So Paschen by Balmer is 9 by 4, but Balmer by Paschen will be 4 by 9. So that is 4 by 9. Yeah, question asked was for Balmer by Paschen. Thank you so much, Winter. Okay, yes. So shortest wavelength is the largest energy gap. Keep this in mind. Okay, cool. Moving on to the next question, which is usually asked in logic gates, related to either truth table or what is the Boolean expression or what is the output, or sometimes the truth table will be given and we identify the gate, or you have to figure out what kind of gate it is, or simplify it. These kind of questions are very common. So look at this. The output of the arrangement of the logic gates is what? A is 0, B is 1. A is 0, B is 1. So B, if it is 1, the same 1 will go here, the same 0 will come here. The 0 will become negative and it will become 1. The same 1 will go here. This is a OR gate. OR gate. So when you do an OR operation, any one is true, it is true. This is also OR gate. You can see that thing, curved line. 1 or 1 is 1. This 1 will carry forward, this 1 will carry forward. This is an AND gate. So 1 and 1 is 1. The negative of that is 0. So output will be 0. The output will be 0. The first answer will be 0. Everybody with me? Okay. So this is there, this is there. C option and D option got eliminated. Now, the next one is A is 1, B is 1. A is 1, B is 1. So if A is 1, this is also 1, B is 1, this is also 1. This B will also go over here. This 1 will become negative, will become 0. 1 or 1 is 1. 0 or 1 is also 1. This 1 and this 1 will come here. 1 and 1 is 1. 1's opposite is 0. So answer is still going to be a 0. Yes, so option A is the right answer. Perfect. How many of you wrote A? Oops, many people wrote B or C. That is not correct, guys. Yeah, do it properly. If you make a mistake, silly mistake, you will get a wrong answer. Great. Moving on. Okay, that was the last question, guys. So we have done a lot of concepts which are repeated along with those applications. I have told you the formula for every single question over here, and I have told you how we solve these questions. So expect these topics 100% in your VITEEE. Okay, so if you do these topics, you will definitely be at a better level. From 11th standard perspective, do thermodynamics, thermal physics, a little bit of work per energy, center of mass, and yes, standing waves you can do. And if you have time, then rotation and SHM, else okay. Gravitation 100%, please do it. Yeah, questions do come from 11th standard from that. And yeah, rest all, it's dicey how many questions they will ask. Now, aptitude and English, if you want me to conduct it, I will conduct exclusive class for aptitude English, but not random questions, in a systematic manner. This concept, this question, this concept, this question, all the models of questions I will cover. Series based, magic square, this, that, whatever, analytical, aptitude, and English also, English grammar, whatever questions they ask, I will do it over here so that you are fully prepared for VITEEE exam. Cool. If you want me to do it, leave a comment after this video. Thank you so much. Spread the joy of learning by liking this video and subscribe to the channel, and let your juniors know as you pass out that you are graduates from Vedantu JEE English channel. Thank you so much, guys. See you all. God bless you all. All the very best. Captain Shreyas sir is always with you.